Men att du spelar in nu och så, det har inte att göra med boken eller?
It has to do with the book. It is helpful to go back to these recordings and see the answers we get from the masters. It's you, Allan Emrén, and I have a third person who's been studying in United States. And it's a better way of remembering the things.
Okay.
And we also get facial expressions.
Yeah, okay.
And oddly enough, that's helpful in understanding something that is quite complicated. Just reading out of a book can sometimes be, it's a bit tough to get into it. I say welcome to everyone. We are currently at Villa Martinsson in Jonsered, and we have the privilege of having with us today Stephan Mangold, the author of Vad väger en tanke och det holografiska paradigmet.
Yes, that's right. Thank you to be here.
Thank you very much, and we will just ease into the subjects and speak about it generally. Me and Kalle Lundahl is trying to find ideas for this book of ours. And in so doing, we stöter och blöter, we are washing ideas in different ways to sort of extract as much as we can. And I start with one subject directly here, which has interesting consequences. A couple of months ago, I encountered something called the Ozma problem. And it was a metaphorical idea made by a mathematician named Gardner, A. Gardner. And he was questioning, is it possible to, if you meet upon an alien civilization, which he named Ozma, therefore the idea of the Ozma problem, is it possible to, we are suggesting or we are thinking in a situation where we could communicate everything with them. So we had like a shared language of sort, mathematics, all those things. So we could tell them everything about our world, including cups, tables, how our nature works. But one thing we couldn't tell them is what's something called handedness, chirality. And he explained that. I didn't understand it directly. I'm a little bit mathematically talented, but it defied answering. But I realized that handedness is an internal feature in something. And it is very hard to transfer the description of what hand I have to another civilization without actually showing that alien the thing. And I felt that to be enormously interesting. A sort of feature of the universe that cannot be reduced by sort of capturing it from the outside, like in the coordinate system where we usually tell what is the size of a cup, how does it look like, these very odd qualities it has from the topological sense, that it is a toroid shape, if am I correct, maybe?
Yes, toroid.
Toroid.
But with a hole in it.
With a hole in it, oddly enough. But this is an internal feature of the universe, and it cannot really be relayed to the aliens. And it just struck me, I never know that were such features of the universe that couldn't easily be depicted within the XYZ of the Cartesian system and all the adjuncts that we have to help us to explain things. Do you have a take on that? Sorry, just to spring you the question. Oh, can't both be seen at the same time?
No, it's too close.
Now let's put it a bit. I want to see. Over here, maybe? Yeah. Now I think we have both. Sorry, Stephan.
I didn't quite get the question really. What is it about? I mean, you said you showed your hand, but
Yes, a right hand is internally chiral in this direction, so to speak. And the left hand has the opposite directionality.
Okay.
And the mirror image of each hand can't be transposed to the origin. And it's, for me, a rather odd feature.
and what has it to do with the alien? I mean, why is it a problem?
The problem is if you can agree on we having the same handedness, both we and the aliens.
Yeah.
So the handedness itself cannot be transferred. So we don't know if they understand it as the correct handedness. Left and right spiraling disappears or cannot be explained over communicative systems. It can only be shown.
Okay.
So it seems to be one of those, how can you say that? Irreducible features of the universe.
Mm-hmm.
And it also has the other feature of the very elementary particles, like the neutrino, for instance.
Yes.
They also have this handedness.
Okay.
And where I think the L-handedness is the most common in our part of the universe, left-handed. So, which are just fascinating. I'm starting out hard here, sorry, Stephan. But it's just a feature that I recently got very interested in.
I'm not a mathematician, but let's imagine a scenario. So, in space, let's say somebody would cut his hand. It's like for a horror movie. But let's imagine somebody would cut my right hand, and then it would disappear into the outer space. And an alien would encounter my right hand. Let's imagine this terrific situation, but you could see it perhaps in a horror movie. So an alien would see my right hand out there in the outer space. And you would perhaps, the alien would ask somebody, what is that? It's a hand, okay, that could alien perhaps understand. But if you would explain to the alien it's a right hand, the alien would not understand it. You cannot.
The word right is not.
It's not transferable.
We don't know their meaning of the word right. But the exact example is they cannot see the hand. We can only try to explain it to them.
Okay.
And handedness, or which is called actually by Lord Kelvin, he named it chirality after the Greek term kairos, which is hand, chirai. And this handedness seemed to be one of those irreducible factors of the reality.
Mm-hmm.
And the neutrinos are one of those things. And it also the difference between matter and antimatter.
Yeah, yeah.
Antimatter is chiral in the other way. So all the features, all the important properties of something is ruled by the chirality.
Mm-hmm.
And it's especially important in chemistry.
Mm-hmm. Okay.
One of those substances, it's a medical substance they used in the 60s. I always lose the name, but it was again...
Levocidine.
Yes. How did you know? That's...
I know.
Well, you know about it. Yes, of course you do. Yeah, sorry.
Because it was when they did all the prototype molecules, they were left-handed molecules.
Ah.
And when they started the production, it was right-handed molecule.
Okay.
Therefore, it was this disease.
Ah.
arms and legs. Which
Yes, yes.
So that then I understand your question.
Yes, thank you. Oh, yeah. It wasn't the best start, the most complicated, of course, but very good, Stefan. Thank you, thank you. How good.
Let me write it here. I only have 3. So this is Greek, it means hand, and in English you say carality, you spell it like it. CH. Carality. So
Okay.
it comes from the Greek. The hand.
All right.
So this is an R, but it is an R, although it looks like a P.
Greek letter, yeah.
It's not easy. And the green. Okay. Here in modern Greek, but in ancient Greek, fair. And as I think it's also good with this, it's because it's a little bit common thought of carality. Also, do you think? Because if I show it here, because let's say this is the right hand, and you could imagine a body, it would be the left foot. So although we normally think that hands are more closely connected, so in a body it could be actually these things that are more closely connected. Right hand with the left foot, anatomically speaking.
That could be a way of remembering it, yeah, maybe, yeah. But the most interesting thing for me was, that struck me, wow, there is an irreducible property in the universe, which we didn't know so much, because this is with the Nevrosidinis is a rather recent happening.
Oh, 60s.
60s, yeah. So we haven't been aware of this feature for such a long time.
But now we are very aware of it, and we check every time that you get the right molecules, if it's left-handed or right-handed.
Yes, yes.
It's the same molecule. And it's also with anis och kummin. That they are right or left.
The very seed?
Yeah, the very molecule.
The very molecule for the smells.
Smell, yeah.
Wow, I didn't know that.
Yeah. So that also right and left.
Because I'm one of these people, I cannot take cumin. I don't know.
Okay.
It's always been the case, I don't like the ones you have in bread, for instance. Or you can get it in the Danish snaps as well. I cannot take it.
Okay.
Whereas anise, I like.
Yeah.
I have nothing against it at all. But wow, this difference in strength. Anise is very strong.
Well, it depends on concentration.
Of course, yes.
So there are very, since that very sad history of the Nevrosidine, because it was very good for women who couldn't sleep. And in the clinical trials, they could also give it to pregnant women.
Okay.
And then they started to make the production, and they got the right molecule.
Yes, just by chance.
Not the right molecule.
No, the right-handed one.
Right-handed one, and therefore all the pregnant women got birth to handicapped children.
Yes, it affected the DNA, whereas
I don't know what it affected.
Whereas the left didn't have that effect at all.
Exactly.
So it makes a great difference, and I think such a difference as matter and antimatter is it's not a slight difference.
And we had also these pills we read in a paper.
Those are those.
This is the same pills.
Those are the ones. No, it's for the book. is we finally found this irreducible feature. It's easy for me to show this to people. They understand handedness. Most people have two hands, of course not all. And they can realize that the mirror image is not the same. It's this really weird thing. And before they see it, I think most people think they are a mirror image somehow, but they are not. There is something more complicated there. And also that the whole property is internal. It twists not from a standpoint of an outside thing. It is twisted in itself.
Okay.
And that feature is quite extraordinary. For me it was. I didn't know about it. You know about it. But for me it struck me, some features are not reducible to the Cartesian system or the Newtonian thinking. And it could be helpful to explain that the most important features of reality are actually internal. So that was the sort of take I took in this direction. Like it begins in a way with the subject, me as an observer.
Yeah.
And it's almost in a way that I'm creating the world, but not completely free. But I am an important feature because without me, and that was the point with this Ozma example, where one of the side points is that without the subject, there's no understanding. This particular feature cannot be understood without a subject. It has to show the hand for the alien. The poor guys living in the Ozma culture. It is a way of showing that the normal mode of thinking, with everything having a place in the grand scheme of Newtonian physics, where everything is determinable, everything is decidable, all of a sudden get this knock on the door. Here we have a property, it's not reducible, it is not explainable in an XYZ scheme because of this odd character or this odd property. So there it's like sort of a backdoor to quantum mechanics to show why the observer is so deciding. We still have some tools. We have, are you familiar with the Necker cube? The Necker cube.
Is it a very odd cube? Is that
Yes, it is a very odd cube. It was discovered, let's see here, in the 1830s by...
Usher?
No, by Necker, a chemist. And he was looking at a certain crystal.
Okay.
And first he looked into that primitive microscope he had. And then he came back and it had changed. And he realized there were certain things that depended on the moment, so to speak. And the Necker cube can be actually projected to 2 dimensions. And it's a cube, you can see it changes from being the front corner, it becomes the back corner, and vice versa. It's a bit like the anagram with the old lady, young lady.
Yeah, okay.
And it's actually changed the chemical. The crystal is get changed by that. So those sort of tools we had only, but they are also good. But earlier we only had those tools. But this with the chirality, I'm really hopeful with it. It could be a sort of backdoor into quantum mechanics where it's a bit easier to explain how the subject enters into the world, so to speak, and make it happen. Without this chemist, physicist Necker being in the room, looking through the microscope, it wouldn't be either or. It would be undecided. So the observer-dependent physics can be explained in that way. A bit easier than Schrödinger's cat. Still complicated, but but you can bring the Necker cube to people. You can show it, and you can use the Möbius strip, which has certain features that it shares, and then even go over to the Klein bottle, which sort of defies the idea of inside and outside. They become the same thing somewhere on that line. What do you think about these approaches to sort of bring in the observer into the scheme?
It's always in quantum physics you have to take into account the observer, because the observer is the person who actually collapses the wave function, and it cannot be whatever wave or particle, but if you observe it, the wave collapses and you detect the particle, so to say. And that's a good example. And if you can make an algorithm or liknelser, what do you call it?
Come again?
Liknelser. Also,
metaphor, trope,
in other areas, so to get a better understanding.
Which is, I will start to do that. Thank you for the advice. And those tools can be very helpful, because otherwise you will like walk around this planet. And I think the common sense idea today is that I am not really important for what happens outside. The world somehow will still be there, out there.
Yes.
And it just exists by itself. And in quantum physics, we know that not to be the truth. At least not the whole truth, if I get it correctly.
The whole truth. I mean, if we just go and look at the Herrgården out there, and if I make a drawing of it, it will be quite different from your drawing.
Indeed, yes.
Because we interpret it differently. So.
The manner. So we are sort of sieving for opportunities to find these pedagogical tools of helping the book, because I think it's an incredibly important mission to make the message that the observer is in on it known to the populace. Without that, you feel sort of weakened within. I can clearly relate to that feeling. I mentioned before, when I was young, it was this fantastic, very modern TV series, The Cosmos.
Oh, okay, yeah.
Led by the American physicist Carl Sagan. And I remember it was really advanced for the time.
Yeah.
And in one of the episodes, they managed to, maybe for the first time, or one of the first time, use this blue screen technique. So they projected Carl Sagan to a cosmic cloud. And he was sitting there looking very cozily. And he was pointing to the universe. Look how grand it is, how immense it is. We human beings are just grains of dust. With no importance at all. And I think through the whole world we all draw a sigh like, my God, we sort of lost our grips. And now we know, after that series in the United States, all these like values of spiritual life disappeared rather quickly afterwards. It took like 10, 20 years since the generation grew up. So it had an immense effect. And one of the ideas here is to bring the subject back. As we seen, we had, for instance, when it comes to the spiritual in India, that they still don't have secularization. When I was in Kerala, I spoke to the clergy there and said, no, we don't have atheism. If we have atheism here, we would have failed in our mission completely. Show me an atheist, one bishop said to me, and I would take down the church. And I think it makes sense. Here we accept it, Swedish church accept it, and that undermines like sort of everything. Then you say there's a physical world out there, and the spiritual world is very narrow, very, very thin. And they don't acknowledge this thing, and they try to avoid it. What do you think about these things? It's something that...
Well, since I'm a scientist, I mean, as a scientist, they said that the spirituality is not there.
Oh, yeah.
That is because... But on the other hand, now, from my own view, I don't think of a god or something, but there is something in the spirit. And there is something which is bigger and not understandable, I would say. And there are different parts which is interesting. One is synchronization.
Synchronicity, yes.
Yeah. And the other is the Nobel Prize in physics last year.
Indeed, yeah.
Entanglement.
Oh, yeah.
And it goes, as you said, left and right, different...
oh, yeah, there's a chirality there too.
Exactly. And if you change from left to right in a particle, and they are separated a long distance, they change immediately. Fast, immediately.
Immediately, without time delay.
Time delay due to the speed of light.
Oh, okay.
And Einstein was the one who didn't like that at all. But now the scientific establishment has granted a Nobel Prize for entanglement, and that it is instantaneous and faster than the speed of light. And that is great.
That is incredible.
That is very, and that is just the start now for the new era.
Definitely. I myself opened a bottle of champagne I had stored away for decades. I think I got it when I was 30, something like that.
Okay.
It wasn't any good.
But you took it due to the Nobel Prize?
Yes.
Oh, okay.
When I got the news.
Okay.
So I had a glass of that. It still had bubbles though, but the color sort of darkened. I was still palatable, was still drinkable. So, and I know there's another friend who studied in the United States. He celebrated, he took a vacation for a week. He went to the Canary Islands, where I think Zeilinger did one of the experiments.
Yep.
Where he proved that handedness goes all over the universe. And if I don't miss, I think the distance was the greatest you can think of. It was like enormous distance between.
Yeah. But they need to be entangled. Came from the same source.
Come from the same source at one instance or other. Well, that goes to definitely show the importance of chirality.
Yeah, definitely.
Yeah, Kalle. Let's see.
So let me see if I can put this on. So let's think about that reality would be like an X, like in chirality. So, for instance, we have an X like in chirality, we have it in, for instance, in the problem of bifurcation, when you have two things going in two opposite directions, depending on the observation. And we can, let's say, develop it further. Say you have this strange cat, you have the cat in the box, you have one possible, before you open the box, the cat can be living or it can be dead.
Oh yeah.
So you can think about it as a two-way direction. So in one reality, towards this direction, it is living, and the other is
Left,
dead.
right.
But there's still something missing. That is the third possibility. It can be both dead and living at the same time.
Yes.
But perhaps it's this option there where they cross each other. So perhaps you could explain everything in the world, including entanglement, strange cat, our bodies, etc., with an X or chirality. And I don't know, what do you think, Stephan Mangold, about my hypothesis, or do you want to add something else? Oh, excuse me.
Oh, okay.
Well, I mean, you just made a conclusion of what we have been talking about. So
Very good, very interesting. Yes.
that is, it sounds very reasonable.
Reality like an X.
Because it's different directions.
Yeah.
It's like a bifurcation. It's often called the bifurcation, which sort of parts the going of time or the development into two different paths.
Yeah, and that is very usual when you have non-linearity.
Okay.
In the equations, and they can be in this direction or that direction. You don't know, because you have in non-linearity this odd behavior.
Okay.
If you have linearity, you can determine everything.
Ah.
But now you have, and everything is actually non-linear. I mean, that it's just if everything, I mean, if you have linear something,
Yes, yes.
that is just an academic example to make calculation.
Oh, is it? Okay. Ah, how interesting. That's
most-
a very
Most is
important
non-linear.
additive, yes.
And then you have the bifurcation, as I also mentioned in my book.
Oh, yes, yes.
You can make house theory if you have a river with water, and you can get the turbulence spirals in the water.
Like a vortex.
You can calculate the rhythm and the periodicity of these virvel, what do you call it?
Vortex or a maelstrom.
Yeah. And but if you take now, you would like to know exactly where each water molecule will come to the end of the where the dam is, and you want to know it is impossible to calculate that. It's no way of doing it, because you have the bifurcation in several places, and there's no way of calculating each water molecule. It is not, it's chaotic, it's not deterministic.
Very interesting, because I noticed that in chaos theory, for instance, we've been looking at hurricanes.
Yeah.
They are also chiral. They could either go clockwise or anti-clockwise, and it makes a difference. It's not the same feature as we usually think. I would never guess that it would make a difference whether they were left or right clocked.
In which way it will be different?
How they move about and the strength of them becomes different.
Okay.
It's a little bit like the molecules that you mentioned before.
Yeah.
Whether they are L, which is left, and or D, they will become different in the system.
Yeah.
And if I remember correctly, most of the building blocks in an organism, whatever it is, I think it's left, L, but most of the products, for instance, sugars that comes out of the systems are D. It's very interesting because nature seemed to prefer one direction to make life, and the other one as the things that are products from life or end products, not as lively. So there seemed to be a connection between chirality and life itself. One of the chaos theorists, Briggs is his name?
Yes, Briggs is.
Briggs. He is speculating that it could be thinking itself, could be left-sided, so to speak, L. And unsuccessful thinking takes more of the other spiral, being the end product, the after effect. And he makes also in this context a connection to what is before and after. David Bohm called it implicit and explicit. The explicit is the D, the right turn, whereas the implicit is life, the thing that you cannot define, not easily capture in an idea, but it's the very soul. Maybe the thing that you mentioned before, there is something, but you cannot really define it, something greater in the universe. This Briggs is sort of, together with David F. Peat, of course, and also David Bohm, the past quantum physicist. I think he also introduced the concept of the holographic paradigm, together with David F. Peat. It's true. So that's interesting. What do you think about those things?
Well, that's very interesting, and therefore it is very important to get the understanding of quantum theory and also of chaos theory.
Yes.
And the chaos theory, there are not just the non-linearity, it's also what you call self-organizing systems.
Oh, yeah.
Which is very, very important to get an understanding for it. And since everything is vibrating, I mean, even if in this air, these molecules here are vibrating with a terrific speed, I mean, about between 2 to 6 kilometers per second. That's very, very fast.
That's quite a lot, yeah.
And if you go into a silent room, a very silent room, you can hear the molecule bouncing at your eardrum.
Wow.
But you have to be there in at least 20 minutes.
Aha.
So everything is vibrating, actually. And so therefore it is very good to get an understanding for the self-organizing systems. If you have a box of particles and they vibrate, they start to go in a round circle to minimize the energy loss. That's one type of self-organizing system. And you have also experienced this if you're in a theater.
When you applaud.
Exactly.
In the beginning, the applause would be disparate. But yeah. And then after a while,
it gets self
always ordered.
They get in the same beat.
Yes.
And that is a good example of self-organization in a system.
I come to think of one thing. Many years ago, I was in Rome, and they have one of the biggest flocks of starlings, starar. I think it's composed of 100,000 or several hundred thousands. But they moved like one hand.
Yeah.
And they were spiraling. And I realized directly there was no chance on earth they can look at the other birds and sort of compute, where should I fly? it was a higher organizing system that happened much quicker than the nerve ends could possibly change there. And it moved like one organism.
Yeah. And it's just not the birds. I mean, there are the fish, like
The fish.
and stim, and they are together, and they also.
Schools of fish, yeah. And that could be even more. That could be millions. And
Yeah.
grasshoppers flying around.
I don't know about that. But maybe.
So this unknown, as you mentioned, could be a higher self-organized principle of sorts that we could interact easily capture in. I always get the feeling this Cartesian or Newtonian XYZ and the T, that stands for time, it's rather limiting. And it doesn't make space for something bigger than that. It's almost like having this your monocular on the reverse.
Okay, it gets smaller.
Everything gets very small. And all of a sudden there is no space, like Carl Sagan. He definitely didn't believe in anything greater than himself or the universe. And he was very good at, he was a nice man, of course. But of course that made his message go through even harder. A very likable and a good scientist as well. Which is in itself a nice combination. But his influence had been incredibly immense.
Yes.
There are several others who are in the same line, but here I think we are, thank you to you and others, we are gathering material to help, like almost using some sort of crowbar to open up these rigid fixations, which sort of tends to make everything smaller than they are. Something Briggs and others, I think David Bohm mentioned that when you enter into the self-organizing principle, you can have self-understanding as well. Like a self-organized structure within thinking that makes it possible for you to sort of feel inward. We call it proprioception.
Okay.
So you can monitor yourself, something that would be very hard to do when the thoughts are on a big line, linear. The linear principle as a sort of non-linear way of conceiving the world, and even the inside as well.
Well.
Åh nej.
We spoke earlier about a dead cat. So I have been asking myself, is death necessary in the system? So to say, for instance, the human body needs bacteria, a small amount of bacteria that is, simply speaking, death in order to thrive. We need, for instance, too much cleanness can cause allergic reactions. So we need bad things for the system to work. Disturbances, so to say. So would you say that death is necessary for a healthy body, so to say? Implicit death, so to say, the bacteria. If you get my point, it's more philosophical.
I mean, if you go let us say you see an airplane in the sky, a jet coming. You get all these strips.
Yes, after it, yeah.
And this is due to the particles coming out from the jet. And one particle makes the disturbance in the atmosphere and gather water molecules around it. You see the white.
Okay, so it's not all coming from the jet.
No. And you can see one jet stream is very, very short.
Ah, yeah.
and there's no very low moisture in it.
Mm-hmm.
If it's very long, it's a lot of moisture in the air.
Ah,
So that is a particle make a disturbance, and you get a system built up around it. Is that what you meant with?
Yes, more like yes. We have, of if you use our bodies as an example, we need bacteria.
Well, we have
This-
2 kilos of bacteria
oh
in our,
my.
in our system. I mean,
Yeah, yes, I had no idea about these jet streams. I thought it all came from the plane.
no,
So it makes a disturbance that causes some sort of self-organized thing.
yeah,
Wow. So the
Because-
disturbance starts the self-organized thing. Well, that's extraordinarily interesting.
it's a good example actually.
Definitely. And I wasn't aware of, of this. This is very good. We are making definite good things here today. Wow, how great, Stephan. So a little disturbance in a moist sky, so to speak, makes for the whole jet stream
Yeah,
to self-organize into this thing.
yeah, because the jet stream gets out all the particles, dust particles. I mean, from the extraction of the fuel.
Of the jet fuel, yeah. So that's how that works. I also read about the galaxies, that they are dependent on a self-organized principle. And despite what one usually think, what brings them about is the disturbances within the system. That everything is different, going in different direction. And that helps to build another type of chirality, the twist of the galaxy.
Okay.
And if it were to, if everything inside the galaxy were too similar, it would be unstable. The regular idea is that we think that by bringing stability, we bring by bringing likewise building blocks like atoms, we bring in stability. It seems to, in nature, not be the case that disturbances like the vortex or the maelstrom in the stream. I think we have a nice river down here, where especially in the spring flood, you can see a lot of these, and they become immensely stable, actually.
Yeah.
And
And if you increase the speed of the river, there will be another pattern.
so it's dependent on the disturbances,
Yeah.
but survives them, so to speak. It's actually a good picture of the human soul. Once it can be let to be disturbed, taking things in, it becomes permanent, so to speak, or more permanent.
So you mean we have a soul?
Well, Briggs and David Bohm was pointing to that it could be a sort of self-organizing principle.
Yes.
And the regular system doesn't make, because of this reversed monocular, makes our understanding too small to see that we are part of this sort of self-organizing soul system.
But you think, I mean, in your book, you tell that we have a soul.
Well, we haven't told so explicitly, but we're sort of pointing to it, the possibility for it.
Okay.
And that in itself, one suggestion, amongst others, of course, is that it's dependent on chirality, and it could be some sort of self-organizing principle.
So if you die, the soul will still be alive.
Yeah, because it's almost like the vortex somehow. I don't 100% remember. It was this metaphor coming from China, and said that the soul is constructed of the body and the matters around, but it sort of has its own vibration.
Okay.
And because of the things around it, it can vibrate almost by itself. And it sounded like when I first heard that, like a sort of a self-organizing principle.
Okay.
And as we've been looking before, this reversed monocular often take those features out of the picture. We want to put everything into the diagram of X, Y, Z, 3 perpendicular orthogonal lines, and we put a time axle, and it doesn't really allow for self-organizing principles. It's highly linear, isn't it? This Cartesian look. And so, yeah, in a way, it makes the possibility open for an immortal soul. Yeah, I would say that, yeah. And, well, you've been to Asia, you know, often.
Of course, but I'm very reluctant to believe that we have a soul. Of several saying that there is no soul.
No.
There is some spiritual, okay? That I can agree on. But I don't know. I'm skeptic to that.
Yeah, I do understand.
But it can be, I mean, all the religions have something to tell about after death.
Oh yes, yeah.
And that's why they make money on.
Oh yeah.
That's
one side to it, definitely. Yeah, of course. There's power and money involved in the whole thing.
Yeah.
And that usually, no, I see those aspects. We were sort of opening up for the possibility of this, and I do like the idea of the self-organizing principle.
Yeah, that is in cow theory. It's acknowledged that. I mean, that is how it is with self-organization. That is no. It's scientifically explained.
Yes.
And that is also the evolution of things, the self-organizing systems that can sort of form
their own organisms, and there were at least 2 biologists coming from Chile, Francisco Varela and Umberto Maturana. And they said they're very interesting because they had this theory that self-organization lies in the bottom of life itself.
Yeah.
And
that is also I've written in my book.
Yes, I know. That's why it was so interesting to bring these things up.
Yeah.
And how it's incredible forceful power.
Yes, it is.
It breaks rocks. We're thinking about I don't know what's called in English, the bear animal. It's a small insect or what it is. I'm not sure. It looks like a distorted bear, but it can withstand low temperatures down to almost 0 Kelvin and still come alive. It can live without oxygen, so they can be on a space shuttle, go to the moon, come back, and then become like Lazaro, resuscitated when they had fresh air again and move about. So self-organization are capable of incredible feats.
Yeah.
There's almost no limit to what it can do.
Yeah. It's very interesting, yeah.
And there is a lot of talk now on the internet about the left hemisphere and the right hemisphere. I don't know if you heard, there's been a development the last, very recent, couple of years.
Yes, only. It began with Matilda Christ, Master and Emissary, published 2009, but it was still a small thing. But it was only now in 2021 when he publishes 2 big books, The Matter of Things, Volume 1 and Volume 2, when he got publicity. For instance, thanks to the comedian John Cleese, who said this is the most important work ever. He referred to Master and Emissary. Many began to read Matilda Christ, pointed out that the right hemisphere is the one that should be, so to say, be ruling. Instead, in the West, we have left the left hemisphere to rule. To make a
the hemisphere, I mean,
The two different brain regions.
okay.
So there's a chirality there as well.
Yeah.
And I had a naive impression before that the brain halves were similar, but they are actually opposing sides. And the corpus callosum we have in between them is not helping them communicate. It's actually stopping the communication. There's a sort of wall against letting the other hemisphere get information about the outside world. And the one that doesn't get information about the outside world is the left hemisphere. Oddly enough, he comes to the same conclusions as we done, Kalle and me, that this limited system I mentioned with the Newtonian Cartesian is situated in the left hemisphere. It's a as he called it, and then he makes a little pause, representational system. So it doesn't really get into the fractal or chaotic reality. Instead, it's symmetrical in its thinking. Everything is linear. And as you mentioned, nothing really is linear.
Yeah.
You hear that? This is coming from science itself. Nothing is linear. But this brain half thinks everything is linear. And it cannot be convinced any other way. And one of his points is the left hemisphere, quite recently, doesn't he say like 100 years has come?
It began slowly already during the French Revolution.
Yeah.
Maclauchlis affirms that it began already with the French Revolution, 1789, and then it has increased this tendency towards the left hemisphere. Here in the Europe and the United States, while you don't have this tendency in India or Japan. So why does he say that it's so dominant? This tendency is so dominant here in the West. There are several reasons for this tendency that the left hemisphere has taken over here in the West. Perhaps Newton has contributed to this Newtonian system, and we think that is the reality. Why in India they doesn't think that Newton's cardinal system is the reality. Maclauchlis doesn't exactly point fingers at Newton, but I think that indirectly or implicitly that something went wrong in the 18th, around the French Revolution, around these years, when Newton's revolution got its big population with Voltaire, and when it reached the big masses in Europe. And the left hemisphere likes to simplify. It likes lines. So Newton's system is consonant with the left hemisphere.
Okay, yeah. Have you read the book My Stroke of Jill?
No, I heard of it, yes. Do tell us.
She was a brain researcher. And when she was 37 years, she got a big stroke on the left hemisphere.
Oh.
And she survived, but she didn't know who she was. And she was like in heaven, in nirvana. And there was only the right which was
working.
And her mother helped her a lot. It took her 8 years to recover.
To recover from the massive stroke.
I mean, she realized how different these two hemispheres are. And she said, if I hadn't been in this situation and we had this experience, I would never believe it. And I took it on my book also.
Yes, I remember. I didn't remember the name only. McGilchrist, which I can highly recommend to everyone, is taking up those things.
Which? Who?
Ian McGilchrist, that's the name of the author of these two books.
Okay.
Is a British, Scottish
Okay.
neurophysicist or psychiatrist.
I think Gill. Här. Gill Bolt Taylor.
Aha, okay. Oh, how interesting.
Nice talk. And she has been also on TED Talk.
Oh, then the second biggest TED lecture ever when it comes to the viewers. Wow. Wow, interesting.
She's born in 19.
First, he wrote that book, and it came out in the early 20th century, 2008 or 9. And as you can see, Stephan, it's quite massive already there.
It was written 2009.
Oh, it was 2009.
Yes.
Lucky stroke.
Before the stroke.
No. Lucky stroke by me. I guess the date.
Yeah, it's very interesting that it is like that, and that especially that she didn't recognize herself even.
No.
She was just in a nirvana. How can that be? And that is because the left brain was just gone.
Out of the concept. He's very close to Ian McGilchrist, and now when he gained fame, he came out with a new book about 2 years ago, and it has a whopping 2,700 pages, something like that. It's enormous. I think this is one of the biggest publications ever. The gathering material, how the different worldviews of the two hemispheres, the left and the right.
Okay. But it would be interesting to see if they have cited her.
Indeed, I'll check it out. I'll check it out. It could be very interesting. I wouldn't think in the first book, though.
Because I always, when I look at popular science books, I always look at if they have a neutrino in there. Then I buy it.
No, sir. Very good. No, as a huge recommendation, and I think it's about time here to, as we say in Swedish, round off. I say thank you very much, Stephan.
Thank you.
As a namaste to you. You are an incredible resource for us in our studies to help with the technical and physical issues.
Thank you so much.
It was very nice of you to come here to Villa Martinsson on a short notice. Thank you very much, Stephan, and thank you, viewers, and thank you, Kalle, for commenting. Bye-bye.